just we can discuss the model in a bit. Yeah.
Yeah, what is the answer? True or false? Kumaraswamy, do you want to try? Just guess. 50% chance. Okay, so in velocity model, we add some noise, right? You remember? Hello. Okay. Okay, fine. So if you are not going to discuss, it will be very difficult for me. Okay.
No, no, no. Continue. Usually, sometimes it is suddenly it doesn't come out in the.
Yeah, it's fine. Okay, so the thing is, velocity motion model. Okay, what happens is your in Gaussian distribution, what happens? Like even if you are very away from the mean position, okay, there is a mean position and you are very away from the mean position. There is some non-zero probability over here, right? So what is the probability that your let's say your robot position is a Gaussian distribution. So there is some probability your position is here. Okay, but there is always some non-zero position probability that you will be on moon also, right? Because this is a Gaussian distribution. The probability doesn't become zero anywhere. It will tend to zero. It will never become zero. Okay, so there is also another distribution called as triangular distribution,
Mm,
right?
mm,
Okay, so there what happens? There the probability is zero outside this, right?
mm.
Correct?
Yes.
Yeah. So what kind of distribution is better? This one or this one for
Now, for
robotics? For
higher sampling rate, triangular distribution is will give good results. Means for higher number of samples.
higher number of samples. Acha. And what is the logic behind it?
Because the endpoints are restricted between two values.
So, okay, so the thing is like it is not necessary, right, that we always use Gaussian, but Gaussian is used normally for large number of applications. You may have to look at the lecture and understand that okay, what kind of noise models are used. Okay, over
Okay.
here before answering here. Okay, so and that is clearly mentioned in the lecture. Okay. Second question is the odometry motion model can be used for state estimation but not for state prediction. Is it true or false? What is odometry?
Odometry
Odometry,
is like
yeah.
the speedometer we have in
Hmm.
a bike or in a car.
Okay. So what basically it
That
does is
that
when
tracks that
yeah.
tracks the how much distance the vehicle has traveled.
Hmm. Okay. Okay. So what is the difference between dead reckoning? You know dead reckoning? Have
Dead
you heard?
reckoning, yes,
Yeah. So what is the
yes,
difference
yes.
between dead reckoning and odometry?
In dead reckoning, I think we know the end result, and with that we calculate the or we try to find out the what should be my value,
Okay. Close, close. So basically
and
in dead reckoning we know that how our system behaves in a certain way that we have some expect model we have, and using that we try to predict, right, what will happen.
Yes. Yes.
Yeah, yeah. And in odometry, what do we do? We have the we
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 have the
have
value.
we have the value, but is that the true value?
No, no.
It
Uh,
is some measured
how
value.
can
Okay.
some
Yeah,
measured value?
yeah. So this discussion should help you in answering this question. Okay. So the
Mm.
odometry motion model can be used for state estimation, but not for state prediction. Is it true or false? Okay, that is what you have to understand. So there is slight difference between estimation and prediction. Okay, so estimation is for what is what is the current state or something like that. Okay, or
Yes.
what is even uh, so estimation is based on certain measurement or certain
Known,
data. Uh,
known value.
yeah, and
And prediction
prediction is
for
based on,
unknown value.
yeah. So you think about that and you can answer that. Okay. The feature based maps are more useful for localization. Okay. There is the assertion,
Yes.
and the reason is the features can be used. So have you solved this assignment already?
Like actually, I haven't solved it. I was 2 3 courses are running on my side. That's
Okay,
why
okay, okay, okay. But you have to
I think
solve
the
it
answer.
in a couple of days,
Yes,
right?
I'll solve it. I'll solve it today or only.
Uh-huh.
But I think
Okay,
the answer is a, both assertion and regions are true, and region is the correct explanation for the assertion.
okay. And why do you think so? What is
Because
the thinking?
feature maps are more useful for localization. Okay, if you know the what where we get an obstacle,
Hmm.
or whether the path is free or not, or is there any object is there that will be helpful for for the bot. And feature can be used for identifying the position. And yes, and if you know the feature at in the map, means the distance is already pre-calculated,
Hmm.
it would obviously help us to find out the position
Okay,
of the bot.
okay. Yeah. So yeah. So basically, if you see the a very simple example, if you take, so feature maps are useful for localization. Obviously, if we know the map, okay, then that is how human beings like have been localizing places and landmarks for a very long time, right? And even today
Yes,
we use Google Maps for navigation. Okay,
yes,
while
yes,
navigation
yes,
we look, okay, where we are. Okay, in Google Map we are able to see a hospital over here. Towards the left the hospital should be, and what is in front of hospital. So based on the relative position of the landmarks, okay, we can
yes.
find out where we are. Okay, or similarly find something else. So these things are useful. Okay,
Yes,
but if you see the reason given, it is said that features can be used for identifying the position of the robot in the environment.
environment.
Okay, and
Yes,
that is why the feature map is useful. Okay, so it is
yes.
very like trivial question. Okay,
Mm.
uh, which of the following are true about occupancy grid estimation algorithm? Okay, so these are the five options. The first option is the algorithm is similar to binary base filter with static state. Second
Mm.
option is the occupancy of each cell is estimated independently. Okay. Third one is the algorithm uses an inverse motion model. The algorithm uses an inverse measurement model. The algorithm needs only the measurement information at each step. Okay. So this is the question. And so what is basically occupancy grid map? First of all, let's see that. Okay, what we do is that space is a continuous space, right? So
Mm.
any coordinate can be given by some real. If I even if I say 2D, we can give by two real numbers, right? But what we do is we discretize it. Okay, like, and we say that, okay, no, 2 points we'll discretize it to the, let's say, two decimal places only. So we can have numbers of the form 2.27 or something like that. or we can say we
Mm.
discretize it by, let's say, up to this is in meters, okay, or something like that.
Mm.
Or we can say we discretize up to 1 meter resolution. So every cell is 1 meter across 1 meter, depending on what is our resolution. Okay. Now here, if we see a binary occupancy grid, okay, binary occupancy grid, we have ones as obstacles and zero as free space. Okay. So this is the binary occupancy map. And how do we put the ones here? Whether we should put or one, it depends on the sensor measurement. Okay, or a prior information about the map. Okay. Then there is another type of grid occupancy grid map, which is not binary. Okay. There you can have the probability of that particular cell being an obstacle. Okay. So here I will have values between 0 and 1. If it is highly probable that that particular thing is an obstacle, then I will put zero point 0.8, 0.75, something like that. And less probability 0.001, zero point 0.1, something like that. Okay. So this is more of a what in the spirit of what is being discussed in the computer science section. Okay. So and this kind of figures you will see. Now the occupancy grid estimation algorithm, the objective of this algorithm is to estimate this grid values. What is the probability value inside a particular cell? That is what needs to be estimated. Okay, that is the objective. And now using this information, okay, if you see the algorithm, there are certain 4 or 5 steps in the algorithm. Okay, and by looking at the steps, you will be able to answer this question. Okay, I will
Okay.
just pull out the steps. Okay, and you look at the steps and you can answer. Okay, but I will not.
Yes, sir. Sir,
Yeah.
can you please explain binary base filter again, if it is possible?
Okay, I can explain binary based filter. I will pull up my previous slide. Okay, okay, I'll just paste the binary base over here only. That would be much easier. Okay, so this is the recursive based filter. Okay,
Yes.
so basically what we do is in base filter, first we use the motion model. Okay, so what is the
Yes.
motion model? Motion models tells you that given an input AUT,
Mm.
okay, first of all you should understand what is the aim of the base filter. What is the aim of the base filter?
The aim of the base filter, as per the equation here, to find out the final position xt. Given we have a previous position and we are taking a measurement ut, and we have a belief
Taken the
system in
measurement
t minus.
ZT. UT is the
Sorry,
input.
measurement is input
Huh,
is yes,
yeah,
and the
and
belief system
previous.
means we have believed that I am present here or in a position
Hmm.
at t-1 time.
Yeah, yeah, yeah. So what happens is at t minus time we believe that we are here. Okay.
Yes, yes.
Yeah. Then what we do is we make a prediction. Okay, we make
Hmm.
a prediction based on some motion model. Okay, this p of xt given ut comma xt minus 1. This motion
Hmm.
model can be like this, that okay, if you move, so this we already have one of the motion models that we have studied in this. There are two motion models we have studied. One is odometry and velocity, right?
Understood. Hmm.
Yeah. So similarly, we can use that over here, or we can have a more simpler motion models, or maybe probabilities. In numericals, they give us the probabilities. Okay.
Yes.
So that you substitute over here. Okay. You substitute the previous beliefs. You take the sum over all the beliefs. Okay. Previous beliefs, and you get the, what do you call this?
this bell bar xt means in time t my actual position.
No, not the actual position. This is the prediction. This is just the
Yes,
prediction.
means okay, prediction.
This is just the prediction. You might be here based on your motion model. Okay,
Motion model. Okay.
based on your motion model. Your motion model is uncertain, is not 100%
Hmm.
confident, na? Okay,
Okay, the
why?
corrections in
From
correction
where?
step I
Okay,
get the
for
actual
example,
position.
can you tell me why? First of all, why are we studying this? Okay, we know this, na? We have already studied this. Okay, if you have studied mobile robotics course, then you know this v cos theta is equal to x dot y dot equal to v sin theta, and theta dot is equal to omega. Right? You might have seen such a, if this is a mobile robot.
No, I haven't
Okay.
studied mobile robotics.
Okay, I am telling you that. Okay, if this is a mobile robot, left wheel, right wheel. Okay, this is left wheel, this is right
Uh-huh.
wheel. It moves
Uh,
with a velocity v. Okay, it has some angular velocity omega. Fine. Now,
okay.
and this is x-axis, this is y-axis. And if I extend this line over here, this is the orientation theta.
Mm.
Okay, you will see all these variables coming up in odometry model and velocity model both. Okay,
Yes, yes, yes.
yeah. So this is the meaning of those variables. Okay, now
Mm.
if you see, we have this equation. Using these equations, if we know the left wheel velocity and right wheel velocity, we can accurately predict where is xy, where the xy and theta is going to be. Then why we need this
Yes.
base filter?
Okay, because of maybe slippages, maybe elevation
Yeah,
problem.
yeah. So the thing is,
This
yeah,
is discussed in the lectures.
yeah, this is discussed in the lectures, but
Uh,
for the, okay, I have to discuss something now.
okay.
Okay, so yeah, so the thing is, we these models are deterministic models, and these models are probabilistic models, and these models have some uncertainty. We use these
Mm.
models because the deterministic models don't work. If we apply the formula, we get the wrong answer. Okay, so
Mhm.
we need to quantify the wrong answer. We need to understand that, okay, my robot will not go over there, but then in what region my robot will go, let us have some uncertainty associated with that. Okay, and I will try to predict as much accurate as possible. Okay, that is the logic. So now when I am applying this first prediction step, I am getting an uncertain value only, but it is a prediction.
Yes.
Now what I do, but I have used information. I use what? Information.
Mm.
Information of, let's say, some motion model. Okay,
Yes.
I have used.
Previous belief systems.
Yeah. Previous belief also I have used, and I have also
Mm.
used some knowledge about the physics of the robot, equation of motions. Okay.
Mm.
Now what I do, I calculate this and I substitute it over here, and I combine it with the sensor model.
Mm.
This is the sensor model. That, okay, if I am in state xt, what measurement I will get. Now sensor will not tell you if you are in xt, it will not say you are in xt. Okay, this is fine. If it is a perfect sensor, you will get xt value. But it also has some
Nice.
noise. That's why you get zt. Okay. So if you use only sensor, then you will be as good as your sensor. Okay, but you can improve your sensor by using motion model, and you can improve your motion model output by using sensor. So here you are combined both the sensor model and your measurement, oh sorry, motion model. You multiply these two probabilities and you get your, okay, this is my uncertain, but what I could, this is what I could do best know about my robot. So this will be some, depending on what your p is, this will be some Gaussian or something, whatever you have assumed. Okay,
Mm.
so this is our recursive base filter. Now you
So,
imagine occupancy grid map like this. Okay, let's say you are a particular at some particular position here. Okay,
mm.
now if I want to fill the occupancy grid map, what I will do? From here, if I want to go here, okay, if I want to go here, what will be the probability my robot will land over here for certain input? Okay, that will tell you whether your robot is here or not. Okay, but
Okay.
okay, so that is only occupancy of your robot, whether your robot is there or not. But your sensors, your range sensor and all, they will measure the occupancy of the obstacles. Okay, with certain, where again, with certain what? Uncertainty, depending on your
Yes.
ZT given XT. Okay,
Mm.
P of ZT given XT. Now that you have to fill in the, for you calculate for each cell and you have to fill the value over here. The belief whether that obstacle is there or not. Okay, like like how we do the belief that your robot is there or not. Similarly, the belief that your obstacle is there or not. Okay, so for
Okay.
obstacles, unless they are moving obstacles, do you need motion model or not?
Mm.
That is what you have to think. Okay, and you go through the algorithm once, then you will able to answer all these options. Okay, I will just
Okay.
pull up the options now. You can once look at it, and then while that will be helpful in while we actually solve the this thing. Okay, the algorithm is similar to binary based filter or not with static state. Okay, with static state, occupancy
It
of
is
each cell is estimated
estimated
independently or not.
independent.
Okay, the algorithm uses inverse motion model or not, or does it use measurement model? Okay, whether it is using ZT given XT, or is it using XT given XT minus 1 and UT. Okay, which one? Okay, so we
Mm.
have discussed some of this thing, and also we
Mm.
have the lecture also discusses, so you have to refer to that conversation. And okay,
Okay.
then algorithm needs only measurement information at each step. Okay, so you go through these things. Okay,
No, no, sir. Binary base. What I understood from the lecture, that means it has two value, either one or zero. If a position is occupied, it will give you a value, or it will
acha,
give you another value.
okay, so okay, you are focusing on this word. Okay,
Yes,
I
because
yeah,
मैं थोड़ा कंफ्यूज हो गया था
हाँ हाँ ठीक है
जब
ठीक है, अच्छा अच्छा, नहीं मैं पूरा बेस थ्योरम बताया आपको, ठीक है,
हाँ
बेस
ठीक
फिल्टर
ठीक ठीक
बताया. ओके, सो बाइनरी, अगर बाइनरी ऑक्यूपेंसी ग्रिड है,
हम्म,
ओके, देन यू कैन यूज बाइनरी बेस्ड फिल्टर इफ यू वांट. If you, it is just for in general, you should use base filter, right?
okay.
Hmm.
So the logic was same, what I said. If it is occupied, it will give you one value. If it is not occupied, or it will give you another value. Was it
Yeah,
is
yeah,
it like
yeah.
that, or it is something different?
So for binary based filter, you are saying. So you are saying
Yes.
whether binary based filter gives only one and zero, not point
Yes.
0.5, point 0.7.
The name already suggests binary.
Acha,
Okay.
acha. Okay, let me just verify this because I am getting little bit confused. Okay, and tell you just now only.
Okay.
Hmm. Yeah, the XT value will be 1 or 0 only. Okay.
XT value.
Yeah, yeah. So, sorry,
How
belief of XT value will be 1 or 0.
1 or 0? That means
Yeah.
XT is our final position.
Yeah. So the thing is whether the grid is occupied or not will be 1 and 0. Okay.
Hmm.
But the way it is computed is recursive base filter only.
Okay.
Okay. So the thing is, the probabilistic models will still be used over there. Okay, it's not that it will be only 1 and 0, but the output will be 1 and 0. That makes sense. Okay. Okay, so let's go on to the next question. Okay, yeah, okay, this is also a simpler thing. In the measurement model, it is reasonable to assume that probability of each measurement value is independent given the current state. Okay,
Okay.
and the knowledge of map is redundant in estimating the joint probability of measurement values. So again, this is a common sense question, not much to discuss. If you have certain doubt, then maybe you can ask.
In general,
Okay. Hello. Can you hear me?
I think assertion is true. Kindly rectify me if I'm wrong.
No, no, I won't rectify you if you are wrong. If I can rectify your thinking. Okay. Why?
Okay,
Why? Why
okay.
do you think?
Because as it says, assume that the probability of each measurement value is independent of given state xt.
Okay.
No, how
So
it
do
is
you think it
independent?
should be independent or it should be
No, no, no.
dependent?
It should be it should be dependent. Otherwise, how can we get into the correct range?
Acha. Okay. So it's good that you're thinking. Okay. I can't tell more than this. Okay. So yeah. So the thing is, the question is not that difficult, and you can answer the
No, no,
question.
it's not that difficult.
Yeah.
Okay.
So which of the following density function is not used for modeling the noise in rangefinder model? Okay. So this is a good question.
Question,
Why do you think Poisson?
because I don't know what is truncated Gaussian, but we have used
Okay,
Gaussians
forget
and
this truncated words. Okay, this word you ignore. Okay,
we have used Gaussian. We have used for exponential also.
okay. So you are doing the elimination algorithm.
Yes.
Okay. So the thing is, you search about all these distributions, how they look, what are their characteristics,
Hmm.
and you will get the answer very simply.
Yeah.
Okay, but notice this one thing that is called density function, right? Density function is not
Yeah.
used for modeling rangefinder model. Okay, so for rangefinder, okay, so what is the major difference between all these four? Okay, one of them is odd man out. Okay,
Mm.
and based on certain this thing, and you will get the answer. Okay, so I have discussed all the questions. Apart from that, if you have anything, you can ask. Otherwise, we can stop for today.
Sir, fine. You can
Okay,
finish.
thank you. Can leave the meeting.
So can you, if you know, did we have, because I couldn't attend yesterday's session, did you have knowledge whether yesterday's session has happened or not? Because
No, I don't
it's
have
not,
any knowledge about that.
it hasn't been uploaded in
Yeah,
YouTube
sometimes
or
we
even,
we don't get time to upload on time, because
okay, okay,
sometimes we need to edit, or sometimes we don't edit and just upload like that only eventually.
okay,
So if we are thinking that we are going to edit, then it takes time.
okay,
Okay.
okay, sir. Thank you.
Okay. Yeah, Kumar Swami, the recording is on my channel always. So if you don't know my channel, I will just send you the link in the chat box. Just wait. Okay, so this is linked to one of my older videos. So on the same channel, I upload the videos. Okay, fine. Okay, I will disconnect if you don't have any questions.